All right, welcome everybody. Hello, my name is Philippe. I'm a developer advocate at Salesforce, and today I'm going to present how you can work with Node.js project that is embedded in your Salesforce DX project. So bear with me, this is the first time I'm coming back to a live audience. I hope you're going to enjoy it. That's my first on YouTube. So today we're going to talk about a couple of things. First, I want to talk about the structure of a Node.js project in general, and then I'll be talking about the different scripts and dependencies that can help us work in our DX project, the things that are specific to a Salesforce developer project. Today, I'm going to work mainly without any slides. That's also a first one. It's going to be a demo-driven session, and I'm going to be taking questions from the chat as we go along. So make sure to subscribe and to like this video if you like it, and the chat will let you connect with us more easily. All right, now I'm going to start with a little overview of our content here, and we're going to look at a terminal here. And sorry, screen is not moving for some reason. Yes, now you see it. Great. All right, so I'm in a terminal on my machine. Whether you're working with a Linux box, a Windows box, or a Mac OS box, you have access to the some of the developer tools like the Salesforce CLI. And in order to start our exploration, I'm going to start with the Salesforce CLI. So I'm going to go with sfdx force project create. This is the basic command that creates an empty project structure, and we're going to explore this empty project to see what's inside this empty shell. So I'm just going to name it demo for now, and I'm going to take a look at this. When I do that, the CLI is going to create a bunch of files, and the ones that are listed here are the ones that you'll find in your repository. This is because there is a plugin that is part of the Salesforce Developer tools, which lets you initialize this repository. So let me open this in Visual Studio Code so that we can take a closer look at this. All right. Let me move it actually on the side. There we go. So now we are in our demo project here, and we have the default files that are generated for our project. And you can see there's a bunch of different folders with names that are more or less obscure for you for now. And my job today is to make sure that you understand what each of these files do. Obviously, you probably know about Force app, but I'm going to tell you about the other ones. So what's important to understand here is that this folder structure is also dictated by the structure of the Node.js project that is shipped with the empty project. So if you take a look at the files there, let me actually boost my font size so that you can see it better. If you take a look at the list of files here, we have a package.json file. And this is something that is typical for a Node.js project. Now, obviously, you're working on a Salesforce DX project, you're not building a Node application. So there are going to be some things that are going to apply to a general Node project and some things that are going to be specific to this kind of deliverable, which is a Salesforce application. Now, let me highlight the most important parts of this file there. In the first header, there's a bit of description on the file. Let's say name, version description. One of the key things also here is the private flag. This means that this is a Node project, but it is not going to be published on a Node package manager. So you're not going to redistribute basically this as a Node executable. This is only here as a convenience at development time for you to run some operations in the background. This is not a Node.js application. The private flag here prevents you from publishing this to a Node package manager. And the description, the name, all of that is strictly internal. It doesn't really matter. Now, there's going to be a bunch of scripts that we can run. I'm going to show you how we can run those scripts using the terminal. Finally, there's a set of dev dependencies. Now, there are two types of dependencies that you can ship, and there are also dev dependencies. So dev dependencies are the ones that are not shipped in the final executable. And since in our case, we're again not building an executable, we will only have dev dependencies. So these are only going to be running on your local machine when you have the project running. If you were building a node executable, then you would have a set of dependencies and dev dependencies. So during this session, I will actually cover all the scripts and all the dependencies, and we'll see what we can do with all of these. And these are the most important parts. I will cover the rest of the configuration later on. So that's really the cornerstone of the configuration of the project, the package.json file. Now, with this structure, we can leverage a lot of tools that are built either by Salesforce or by the community to make your life easier. And among the things that I'm going to cover today are some of these scripts locally on your machine when you work with a revision control system. So I'm going to start by looking at the different tasks, and we're going to explore what are the dependencies and how the different files help you configure those dependencies. The first thing I want to cover is likely the first thing you need to do when you install a new project. You want to, of course, create the project structure, but you want also to install the node project, because by default, you have the package.json configuration file, but the dependencies are not yet installed. So this means that the scripts that are defined here are not yet accessible to you. To do that, I'm going to open a terminal. So I will use the one that is bundled in VS Code to run my commands here. And I need to run the first command. So in my case, I'm going to do npm install. npm is the node package manager. There are several node package managers. Here in this demo, I'm going to be using the npm version, the default package manager that is installed with Node.js. But there are alternatives to this. You can install, for example, another one which is called Yarn. I think both are equally great, and from my understanding, at some point, Yarn was created because NPM was lacking some key features, but nowadays they're pretty similar, but obviously you can have your own preferences. I will use NPM again because it's installed by default. It doesn't need any extra installation. So whether you use npm or yarn, you need to run your node executable command here, the command from the package manager, and then another command. Whether it's yarn or npm, the command we run first is install. So by doing that, what is going to happen? Actually, I'm not in the right repository, in the right folder. Sorry, let me just go one level deeper. So I'm running this npm command here from the right directory. I was one level up. I had two demo folders, so now I'm in the right folder here. And let me get rid of this one. What will happen now is that when I run this with node npm install command, it will fetch the dependencies that are configured in my package.json. So it will take a look at all the dependencies that are defined here and fetch everything we need to run them locally. This will create a folder called node modules. Now, the node modules contains our direct dependencies, but also the transitive dependencies. So if we open this node modules folder, you'll see that it's pretty large and it has a lot of subfolders, things that are not necessarily included directly in our dependencies. And the reason why we have all of these folders is that maybe, for example, Eslint has some sub-dependencies, or any of these things have a lot of sub-dependencies. So node modules is in fact some sort of flat list of all the different dependencies and sub-dependencies that we'll need to run our scripts. Normally, you won't need to export node modules, it's just there. And one of the best practices you need to adopt is generally to avoid putting that into source control, because node modules can be quite large and you don't need to actually keep them. You can regenerate them starting from the package.json. Now, another thing that was generated when I did an install is a package-lock.json. This thing here is, I would say, it's called a lock file. Now, depending on whether you run npm or yarn, the file will take a different name. Here for npm, it's package-lock.json, and if you take if you take yarn, you have a yarn lock file. Now, this is essentially a a map or some sort of dictionary of what is contained inside Node modules. It will take all the sub-dependencies that are installed with their specific versions, their requirements, possible incompatibilities between the different dependencies. It's a very large file, by the way. So it's automatically generated, and you can see here, it's already almost 9,000 lines. So normally you don't take a look at this. You don't even need to worry about this. It's just to keep a, I would say a screenshot or a photograph of all the dependencies that were installed at some point in your project. Generally, it's fine to keep the package.json in your project structure. It will change each time you update dependencies, but it's safe to keep it in the in your project. Now that our dependencies are installed, we can take a look at the different scripts that are provided in package.json. So going back to my package.json file, we have all of these scripts. So I'm going to start first, not by the top one, but by the first one, which is preacher. So preacher is a formatter. What it does essentially is that it applies some standard formatting rules to your project, and it will rewrite all the file types that are specified in a command. So it can work with Apex files, it can work with JavaScript, XML, etc. And the way it works is that there is a preacher core library, and let me now switch to the dependencies. There's a preacher core library, which is here. And there are a bunch of plugins that go along with it. So for example, just below we have a preacher plugin Apex, which adds support for the Apex language to preacher. And there's also another one that we use, this one, plugin XML, which adds support for XML files. But by default, preacher itself will support HTML, JavaScript, CSS, and a bunch of other file formats. With that, we can use the scripts that we have in our lists here, and we can use the first script here. Now, the way scripts work is that they're a dictionary. So you can see I have a list there with key and values. And the keys are something I'm going to be able to call from the terminal. So whatever the script name is, I can always run the script by doing npm run and then the name of the script. So if I take, for instance, my script that I also call preacher, if I do npm run preacher here, this will in fact execute this behind the scene, this large command with all of these flags, which actually include all the different file types that are in my project directory. Now, instead of reminding myself of all the different files here, I can do this as a shortcut. What's interesting also is that the scripts that are run in this context, in the context of these npm scripts, have access to the Node modules binaries. So for example, on my computer, I haven't installed preacher globally. I have only installed preacher in the context of this specific Node project. I could also decide to install preacher globally so that I could run it from any terminal, but I prefer to keep this dependency specifically for this project. And because I'm using a script, the script is able to look in our Node modules project and find the preacher executable that is specific to this project. So it will go in Node modules and find a subfolder called .bin and find preacher in there. You can see here I have a lot of other executables that I can use. And yeah, I went a bit fast. Preacher's here. So that's a quick shortcut. I could also do the same thing. Instead of running npm run preacher, I could just go into the subfolder and get a node modules.bin and then call preacher from here. That'll be the same thing. Now again, if you're using yarn, the syntax is a bit different. Instead of doing yarn run preacher, you would do yarn and then just preacher. The run keyword is optional when you work with yarn. Now that being said, let me kick off this first script. I'm going to run npm run preacher, and you can see here a bunch of output. And what this means here is that I have a list of files that were scanned and rewritten by preacher. The ones that are in clear here, in a brighter color, are the ones that are specific, haven't been rewritten, sorry. The ones that are in gray haven't been touched. So what happened with this one, for example, is that there probably were some line breaks which weren't acceptable for Preacher. So if we were to open it, we would see some differences. But right now I haven't connected my project to any Git, so I cannot compare them. Let me do that now. So I'm going to do a little parenthesis here, going outside of the Git of the npm script. I'm going to initialize an empty Git repository at this point. Now I can actually start to track the changes in my project. So this is just by running git init, I created an empty Git repository on my local machine. What I'm going to do now is I'm going to just commit everything so that you can see the changes as I make them. So I'm going to do an initial commit on my local project. Oops, sorry, I need first to add everything to this commit, and all right, here. Now everything is in my local Git project. Now, if I were to make some changes to a file, like for example the JS-config file here, so let me, for example, introduce some line breaks, mess up a bit with the spacing, for example, and then run again the Preacher script with npm run Preacher, we'll see that the file changes and is being rewritten. Here you can see that it got rid of my extra spaces there. It did keep the line return I've introduced here. I can just remove it to get back to the original format. Now obviously this is a very simple configuration file here, but as your code base grows, the advantage of using Preacher is that the code will look exactly the same no matter who wrote it. So if you have different developers with different coding styles, some that prefer, for example, to have braces on top of a line, or maybe some who prefer to put braces on the next line, well, by running Preacher, you'll make sure your code base looks uniform, and that some rules that files all look the same. Now I haven't configured this. I haven't saved actually. That's why it didn't change. Let me rerun it again. There you go. It put the brace back on top. So this is the default behavior. It will rewrite the files according to some set of rules, but I haven't talked about the rules yet. The rules for Preacher are defined in a bunch of files. There's a .preacherrc file here, the root of the project, which specifies the different rules for the different types of files, and also specifies plugins that are going to be used. My preacherrc file looks pretty empty right now, and the reason why it is empty is that I have kept mostly the default rules. You can look at the Preacher documentation and you'll find there are a lot of different rules that you can use. For example, you can configure Preacher to replace spaces with tabs depending on your indentation preferences. You can also configure Preacher to work with comments, inline comments, instead of having comments on separate lines. You can also toggle, for example, trailing commas. So trailing commas, for example, means that if you have an array here like overrides, you would be placing an extra comma at the end of the arrays here. That's not a syntax error, but some people don't like it. So by specifying trailing comma none, I don't have this trailing comma. If I were to specify that I wanted a trailing comma, I could activate this rule. So this is very empty. Again, I just have this single rule here, and the rest of the configuration here are overrides. The reason why we have overrides is that we need specific parsers for things like the HTML template for Lightning Web Components. We have a plugin that parses specifically the HTML. The reason why we have this is that we have, for example, attributes with special syntax. When you have a dynamic attribute, you have a curly braces in the HTML syntax, which is not standard. So we need to have the specific parser for HTML files inside our Lightning Web Component folder. And the second parser we have here is for Aura components. Because they don't have an HTML extension, there's .cmp, .page, or .components. We need to use an HTML parser to read those, and the HTML parser is already bundled by default in Preacher. So that's an overview of the configuration for Preacher. Another thing that is important is the .preacher ignore file. The .preacher ignore file lets you exclude some folders and specific file types from Preacher rewriting. And by default, we have a bunch of these folders that are already excluded. The first one here is the static resources. So if you have static resources in your Salesforce DX project, here there's none because the project is brand new, but you don't want necessarily to rewrite them. Specifically, if you have, for example, third-party libraries that are JavaScript, they may be minified, and you don't want to apply Preacher on a minified file, because the advantage of having a JavaScript minified is that all the line breaks are removed to keep white spaces to a minimum, and basically to reduce the file size. So you don't want to touch your static resources. You generally want to exclude them. And then there are a bunch of configuration files, so local service for AWC local development. These are automatically generated files. You don't want to touch them. SFDX is for the local CLI configuration. You don't want to modify that because this is also automatically generated. VS Code is for your project settings in Visual Studio Code, also automatically generated. You don't want to touch that. And finally, down there's a coverage folder. This is generally coming from an execution of Apex tests, or also jest tests. This is calculating the line coverage for tests. Also automatically generated, so not covered by Preacher. But if you want to add anything else, you can add specific folders or file types to this list, and these will be excluded each time Preacher runs. So we saw the basics of Preacher. There's also another script that I want to show you that works with Preacher, is Preacher Verify. What I have in the first script is a write parameter, and in the second script we have a list different. So let me break one of my files here, like for example this one. I'm going to add a trailing comma to this list, there we go. I'm going to add a trailing comma to this list here. And if I run now the second script, npm run Preacher Verify, you'll see what will happen. This will look at all of my files here, and it will inspect and find the files that are not matching my rules. And for example, here it found that my package.json is non-compliant. So verify means that it doesn't write. It just lists you different files that are not matching the Preacher format, and write overwrites those files. So that's the main difference. So typically what happens is that locally you will run Preacher to overwrite the files before you commit them to your remote repository. And then in your continuous integration, you'll want to run Preacher Verify so that it doesn't touch your source code, but it does check that it's matching all the rules that are defined in your Preacher RC file. Now, I mentioned that we're working with a Git repository, for instance. So you can work with different types of repositories, and whenever you install the project, it's going to look for any remote repositories, and you can trigger some automation when you integrate with this remote repository. I will show you that near the end of the presentation. I will show you how you can automate applying Preacher before doing a commit, and we'll do that with something called Husky. Now that we've covered formatting with Preacher, I want to continue with the next task you can do with the script. I want to talk about linting now. Linting is a bit different than formatting. I think it's important to understand the difference. Formatting is essentially things like white spaces, line return, brace positions. It's not something that will impact the actual code. It's more something that is pleasing to the eye. Now, linting is one step further. It does some sort of static code analysis, and it can help you figure out potential issues with your code. So for example, when you're linting, you will detect unused variables, unused functions. It will detect, if you try to overwrite a constant, if you try to access things that are not necessarily exposed, for example. And if you, for example, have unused imports, things like that. To work with linting, we leverage something called Eslint, and Eslint is the most widely adopted JavaScript parser and linter that is out there. So let me now go to the dependencies. There are quite a few linting dependencies that we use. We will use almost 10 of them, but the core one is called Eslint. That's the main one here. Now I'm going to cover all the different plugins we have, because it's rather complex, and I think you need to have an overview to understand what these are doing. So the first one is Eslint. Eslint only covers basic vanilla JavaScript. Obviously, we want a bit more than that, so we're going to have to add a couple of plugins that are specific to Lightning components. But by Lightning components, I mean Lightning Web Components, but also Aura components, because these are specific syntaxes and specific additions to the JavaScript general language. So let me go from the top down. These are not necessarily in the correct order for my explanation, but at least I can explain all of them without forgetting any. The first one here is the plugin that adds Lightning Web Components support to Eslint. And things that it can help you with is, for example, the decorators. So for example, the regular Eslint wouldn't know what @API is or @wire is. And with this plugin, we add support for specific syntax, experimental syntax with the wire adapters and such. Then further down, we have the Eslint config LWC. Now, just like for Preacher, there are some different rules that you can enable or disable depending on your choices. Whether you want to have stricter control or whether you want to ignore some rules is up to you. You can, of course, disable the rules one by one or explore them one by one, or you can benefit from configurations. Configurations is basically a set of rules that are enabled by default. And this plugin, Eslint config LWC, ships with a bunch of configurations that are ready made for you, and you can just enable on the fly without having to specify every sub rule. So generally, we work with Eslint config LWC, and we use the recommended configuration from this. And this picks rules from the plugin dependency. Then we have a plugin which adds support for Aura language. If you don't plan to have any Aura in your project, well, you could decide to remove it. There's another one here which wraps together the Aura and NWC plugins together for more consistency. And if we go down there, we have a specific config that actually is no longer needed. This will be removed in the future, but this was a configuration that adds extra compatibility between Preacher and Eslint. Sometimes there could be some conflicts between the formatter and the linter. This is no longer required, so this will be removed in future versions of the project structure. There is this one, which is a set of rules specifically designed for imports. This will check for unneeded imports and specific conflicts between your imports in your JavaScript files. The next one is specific for Jest. Jest is being used to test JavaScript, and in particular Lightning Web Components. This particular plugin here will check, for example, if you have tests without any assertions. So that's a pretty common thing you want to do. And by having it here in our lists, we can have those rules and leverage them to make sure our tests are properly written and we're actually writing the right kind of assertions in our tests. And that's it for the lists of plugins that are required for linting. Let me now look at the scripts and see how we use those different scripts, dependencies, sorry. So right now, this is also something that will evolve in the future. We have a first script called lint, which actually runs two subscripts, lint LWC and lint Aura, which are defined down there. At the moment, there are three things here which are kind of similar. The idea is that we have split Aura and LWC linting into two subscripts. This will be removed in the future. You'll only have one lint here, which will lint everything. So let me show you how this works. Again, I'm going to go in my terminal and I'm going to do npm run lint, just because the name of my script here is lint. It will fire the two scripts one after the other. At this point, there are already some errors. Let's see. Yep, of course. So it's complaining at this point because there are no files. And you can see here, they didn't find any files for LWC. So I will need to create some Lightning Web Components. Let me do that very quickly. I'm going to create a, Actually, I need to reopen my project in the right folder. Let me just do that right now. This will allow me to have the right extensions. All right, sorry for that. By having the demo project directly open at the top, this allows me to use the VS Code extension. So I can actually do a right click from here and create my Lightning Web component directly here. So I'm just going to create a very simple file here so that it at least has some Lightning Web components to run the linting on. So again, if I now run again npm run lint on my project, it will pass without complaining. Oh no, it's complaining now, but I don't have any Aura. So let me also create an Aura file, an Aura component. All right, creating an Aura component. So at least it has some files and it's going to be able to run lint. Let me clear my console here again. All right, it's linting LWC, linting Aura, and oh, still complaining. Why is it complaining? Yeah, it's complaining that some things are not used. So it was looking at my Aura file and it saw that I have some, in my JavaScript for my Aura file, I have some unused methods and unused parameters, sorry. So if I take my controller here, it's complaining that these things are not used. And you can see here in VS Code that these are highlighted in red. And this is because I have installed in this particular project, not in the project, in my general configuration, I have installed an Eslint extension, which leverage my project configuration and does some highlighting. So what I could do here is I can actually remove them because they're not used. I can do that with a quick fix. I could add I could do certain things. I could rename it, but this is not going to change, but it's still going to be unused. But I can also disable the rules there. So the no unused vars here is a specific Eslint rule that checks for unused variables. And you can see here I can already disable it for just this particular line in this particular file, or I can disable globally in my entire project. So for example, if I do that here, this will add a comment, and this comment has a specific syntax. First, there's a keyword called Eslint disable next line, and then the name of a rule. So the rule that was breaking for this next line was no unused vars. By having this comment here, the linter will pick it up and will be able to ignore errors on this particular line. Now, if I go again in my terminal and run one more time linting, we will have normally no errors. Yes, and it succeeded. So that's one way to specify the rules. And let me now show you a bit more in detail how the rules are defined normally rather than exceptions. So if I close everything, at the top of my folder in my root project, I have a .eslintignore file, which works very similarly to the preacher ignore file. So we can list a bunch of files and folders which are ignored. Now, remember that ESLint only works with JavaScript, so that's a big difference with Preacher. It will only scan for JavaScript. So all of the other file types need to be excluded. We're only looking at JavaScript files. And then the rest of the config is not placed at the root of the project. We could have an ESLint file, configuration file at the root, but what we have done here is that we have configuration files specifically in the subfolders, in Aura and LWC, because there are specific rules in there. So you can see here we have .eslintrc.json files, and there's another one down there for LWC. The reason why we have separated these two things is that there are different rules for linting Aura and linting Lightning Web Components. So let me start with Aura. Here, this is a standard ESLint config file. It starts by declaring a list of plugins that are going to be used. Here you can see that we have used the plugin which adds Aura support to ESLint. And we have a set of configurations that we're going to use. I mentioned that configurations are a group of rules, and we are starting from two different groups of rules. The first one is coming from the Aura plugin. It's the recommended set of rules. And we're extending that by also adding some specific rules that we have disabled here. The first one here, for example, what means that we have we need to have all variable declarations on top of a file or top of a method. And the other one is that we support or not for the helper and the controller, which are defined, which are related to preacher. This will be removed in the future because there's no more conflicts between preacher and Eslint. But what's important here is the default or a set of recommended rules. If you look at the other file, the configuration file for Lightning components, we have no plugin, but we have the recommended set of rules for Lightning Web Components and also preacher. Now there are some overrides, some things that are overridden, and you can see that the way overrides are defined in this instance are a set of files. So here we took every .test.js file, so these are specifically just test files for Lightning Web Components, and we have disabled certain rules. For example, this one, which means that you cannot use wires that are not defined locally. Now, the reason why we have this one here is that just tests runs locally on a local machine, so it will not check whether the wires exist on the remote org, and it will not trigger errors. That's why we have disabled this one in the context of jest. So that's really the basics. There are lots and lots of rules that you can use in Eslint, and depending on your personal preferences, you can add these rules to the .eslint.rc files and extend them. Let me just go back now to package.json and talk to you a bit more about the different actions you can run. So we saw formatting, we saw linting. The next step is to take a look at testing. I'm not going to talk about Apex here because Apex is being tested on the org, but now I'm going to talk about testing for Lightning Web Components, which is going to be run locally. For testing Lightning Web Components, we use this, oops, I didn't mean to click on that one. Okay, never mind, it's running. We have the test command here and a bunch of other testing shortcuts that we have down there. And let me show you how this works. First, let's talk about the dependencies. The core of what we need is here. This dependency here brings together everything we need to test our project. And this is called sfdx LWC jest. This is in fact just a testing library for JavaScript, vanilla JavaScript, that is bundled together with a specific plugin for Lightning Web Components. Now, to the difference of Preacher or Eslint, we have bundled together jest with the Lightning Web Component plugin into a single dependency. So that's a very different architecture, but we've done that to maximize the integration and to simplify the setup. With that, we can run the sfdx jest LWC executable with a bunch of scripts here. So this one is defined in isolation. You can see that there's a simple test command here, which in fact will run test unit, which is just down there. And we'll call the binary for the library sfdx LWC jest. By running it by default, it will look at some basic configuration rules, and we can add some flags after that to add extra parameters. So whenever you create a project, you need to have a jest config file at the root of your directory, of your project directory. And what this does in the context of a Lightning Web Component project is that we need to add a specific configuration to the basic jest configuration. So here what we do is that we load the specific configuration for Lightning Web Components, and we add it to the default jest configuration, and we can also decide to ignore certain files that are located into some patterns. This particular line here is helpful because it allows us to ignore the local development server JavaScript files that may be generated when we test Lightning Web Components, and we don't want to include those in code coverage completion. So we ignore this particular local dev server with that, ignore pattern. Now, this is a very simple file here, this simple configuration file, but when we move to more advanced configurations, in this config file, you'll be adding mocks. So for example, if you want to simulate things like complex interactions with a base component or loading a third-party library, you would be placing mocks into this jest configuration, and you would be adding some high-level configurations in there. The structure of this file is not specific to Lightning Web Component. It's something that is defined by Jest itself. The only thing that is specific to Lightning Web Component is the injection of this particular Jest config for Lightning Web Component, but the rest is standard. So let me now, instead of continuing the demo with this empty project, I'm going to open one of our sample apps because we want to have some tests so that we can show you what is going on. So I'm gonna open one of my other projects. Let's see, Dreamhouse, for example. Switching to Dreamhouse, which has a bunch of Jest test files, and you can see that we have exact same package.json file in there with the same scripts. So I'm going to run tests there so that we can run the test for Dreamhouse. So now I can just do npm run test. So I could do it this way because the name of the script is test. But test also is a specific keyword for Node. So I can also use a shortcut and just do npm test. It will do the same thing as npm run test because test is a specific keyword. Now doing that, it will load my Jest configuration file and it will run my tests. Here you can see the list of Jest test file it found. It runs them in parallel and it will execute them one by one. It will take a bit of time here because I have quite a few of these. So while this is working, I can actually show you the configuration that is a bit more advanced in the context of this sample app. Oh, there's some errors. Okay, I guess I need to update the repo. I don't have the latest version here. Anyway, I wanted to show you, while this is running, mock base components, for example. And here we have in this advanced configuration for Jest, we have a modules name mapper directory key here. And what this means is that we can replace certain imports, so everything that is Salesforce schema, with other types of files. So instead of loading a wire adapter, or instead of loading a base component, we could replace this with something that is mocked in our local project. So let's take an example, for example, in consideration. For example, this one. Here we're replacing all imports for Lightning navigation with something that we have defined locally. And the root here is the root of our project directory. And force test mocks Lightning navigation, we have another JavaScript file that will replace the default Lightning navigation service. So if I open this actually test Lightning navigation, and you can see here, this is a mock that will replace the use of the default navigation service with something that we have defined. And so we've just replaced it so that we could actually track what is being called. It doesn't do navigation on its own, but it will actually simulate navigation, and we can actually make sure that we have, for example, navigation to specific URLs this way. It's an advanced way of testing. This is not specific to this service is specific to Lightning Web Component, but mocking modules is not specific to Lightning Web Component. It's something that is done with Jest. All right, so we're nearing finishing the list of configurations. I want to take a look now at the time here, just to be mindful of your time. Yeah, time is running out, so I'm going to try to hurry a bit. One last thing I want to show you is that we can run pre-commit scripts. And the way this works is that when you run an install of your package with npm install or yarn install, it will trigger a post-install script, which is a default lifecycle hook. In your default project, you will only have Husky installed. Husky is a dependency that allows you to connect with Git and trigger some events like commit, pre-commit, and we can run some scripts with that. So very quickly, when you run Husky install, it will let you call a pre-commit script. And here, for example, we call lint stage, and lint stage runs a bunch of commands on the different files that are being pushed to the commit. So each time there is a class file, it will run preacher write on it. Each time there is a CSS file, it will run preacher on it. Each time there are some files which are our Lightning Web Component, it will run Eslint. And same thing, if you change some test files, it will also run sfgx wcjest on these specific files only, not on everything in your code base. So lint stage is only running those commands on specific files that are being changed in your project. All right. So that's it for today. I'm running short on time. I will take some time to answer some questions. I'm going to have a look at the chat very quickly here. I've totally crashed the iteration I had planned for this. I went a bit further in detail than I had expected. So let me take a look at the questions in the chat. All right, don't see that. One sec. I lost my window. Bear with me. Questions coming in. Iteration. All right. So questions. Can we include npm dependencies in LWC project? Will we be able to bundle dependencies and put them on platform? So the answer to that is not simply, because the way npm works is that it bundles everything in Node modules. If you want to bring a third party in your project, you need to get the binary of your project and put that binary inside a static resource in your Force app project. Now, you could write some scripts, some Node scripts that take your dependencies and rewrite them so that they're packaged as static resources, but generally the most convenient way of doing this is to simply pick the binary of your dependency that you want to include and put it in your static resources folder, not using npm. Yep. Not a lot of questions here. Okay, that's good because we're a bit late. There will be a I'll be sharing a blog post that contains all the information we've covered in today's session, with maybe a bit more details on some specific topics. For example, the pre-commit hooks. That was the first overview of what you can do with Node.js project. I hope you've learned some new things and I hope you enjoyed it. Remember, Node.js is very convenient for doing some automation. Here we only scratched the surface because we only talked about what you can do in your local project, but a lot of these scripts can be reused and are actually reused on CI systems. If you want to learn more about this, you can check out the sample apps like Dreamhouse, for example, and look at the CI configuration, and you'll see that we run the same scripts, the lint scripts, the prettier scripts. We all run these scripts also on the continuous integration so that we can ensure that we have clean code both locally and in our Git repository. That's it for me. I want to thank you for joining today and listening. Make sure that you subscribe to our channel, and if you like the video, let us know. And if you can hit me on Twitter